Dear students, last class we discussed about different devices used for measuring fluid pressure. So today uh, we will derive the equation to find out the fluid pressure or the liquid pressure. First, using U2 manometer, simple U2 manometer. As you know, simple U2 manometer has a U shape. It has got left limb and right limb. Here you can see in the diagram, the left limb is connected to the pipe A, in which the fluid, the pressure of which has to be measured, and the right limb, it is manometric liquid, that is darkened, that is usually a heavy liquid, mostly we use mercury. So we will check how we can derive the equation. First, we have to draw the datum line. Datum line, as I said, for U2 manometers, the bottom level of separation between the liquid in the pipe and the manometer liquid. You can see that is shown as XX. Now we have to find the height. In the left limb, the liquid passing through the pipe that is connected to the left limb. The height is H1 from datum XX to the center of the pipe. And in the right limb, it is marked as H2. That is the height of manometer liquid from the datum XX. So H1 and H2, two heights are there. We can see that. Let H1 is the height of liquid in the left limb above the datum line XX, measured in meters. Unit has to be in meters. H1 is the pressure head in the left limb. Pressure head, you know the some difference between pressure and pressure head. Pressure is equal to rho GH, where H is a pressure head. That is, pressure head has to be multiplied. It is a proportional value. It has to be multiplied by density and acceleration due to gravity to get the pressure at that point. Okay. So we have going to calculate the pressure of the liquid inside the pipe A. Okay. Now H1 is the height of liquid in the left limb above the datum line XX, measured in meters. H2 is the height of heavy liquid. Usually mercury is selected as a heavy liquid in the right limb above the datum line XX, measured. That is also measured in meters. Now the specific gravity of the liquid in the pipe. What is specific gravity? Specific gravity, Courant, that is the ratio of density of the liquid divided by, or density of the liquid to the density of the standard liquid. Standard liquid is water. So density of liquid, given liquid, divided by 1000, because density of water is 1000 kilogram per cubic meter. Okay. Now S1 is the specific gravity of liquid in the pipe. That is the pipe A. And rho1 is the density of light liquid in the pipe. As I said, manometric liquid will be heavier than the liquid in the pipe. So we can calculate the density is equal to specific gravity into density of standard liquid, because specific gravity is density of liquid by density of standard liquid, that is water. Density of water is 1000. So we can calculate the density of light liquid in the pipe is equal to specific gravity of liquid into 1000. That is, S1 is taken as the specific gravity. So S1 into 1000. Now the specific gravity of liquid in the manometer, that is manometric liquid. S2 is the specific gravity. So density of the heavier liquid or manometer liquid can be found out by S2 into density of water, that is S2 into 1000. Now P, let P be the intensity of pressure in the pipe, which is to be measured in Newton per square meter. That is why we have taken the pressure head as distance in meters. Okay. We know that pressure in the left limb above XX is equal to pressure in the right limb above XX. That is what the principle based on which manometers are working. That is liquid column balancing. Liquid column in the left limb is balanced by liquid column in the right. Okay. So pressure in the left limb above XX is equal to pressure in the left limb on the right limb above XX. See the diagram again. Pressure in the left limb above XX, that is H1, plus the pressure in the pipe. So you have to understand that inside the pipe the pressure is there. Let it be P plus the pressure inside the left limb of the manometer is equal to, that will be balanced by the pressure of the manometric liquid in the right limb. Okay, or the weight of the manometric liquid in the right limb. Now we can see that how we calculate pressure in the left limb above XX, that is pressure of the liquid in the pipe, that is P, plus in the left limb, what is the pressure? Because height is h1, so rho 1 gh1, that will be balanced by pressure in the right limb above xx, because we have calculating or we are balancing it from a datum line. Both sides we have to equate the pressure. So P plus rho 1 gh1 is equal to rho 2 gh2. So P will be naturally rho 1 gh1, h1 will go to the right side. So rho 2 gh2 minus rho 1 gh1. Okay. So this is another simple diagram. It is more simple. I have given it here. See, U-shaped tube is half full of liquid, one side of which is connected to the region of interest and the other side to the reference atmospheric pressure. See, the left limb is connected to the pipe, that is the region of interest, because we have to calculate the pressure inside the pipe, pressure of the liquid inside the pipe. Okay. So right side is open to atmosphere. The difference in height of the liquid pressure represents the applied pressure. Applied pressure will be the difference of pressure. Okay. Pressure at xx in the left column is equal to pressure at xx in left column. Okay, is equal to pressure at xx in right column. Okay, pressure at xx in left column is equal to pressure at xx in right column. They have given it wrongly. Left, that is right column. That is P plus rho 1 gh1 is equal to rho 2 gh2. P is equal to rho 2 gh2 minus rho 1 gh1. Now P is equal to rho gh. We know that P is equal to rho gh because h is the pressure head in terms of. So rho gh is equal to rho 2 gh2 minus rho 1 gh1. P is equal to rho gh. Okay, rho is the density of liquid in the pipe. G is the density, acceleration to gravity. H is the height of liquid. So rho gh is equal to rho 2 gh2 minus rho 1 gh1. H is equal to rho 2 by rho into h2 minus rho 1 by rho into h2. That is h is equal to h is equal to s2 h2 minus h1 h1. That is another derivation. Okay. So we'll go to the former one, that is P plus rho 1 gh1 is equal to rho 2 gh2, that is P is equal to rho 2 gh2 minus rho 1 gh1. This is the general equation for finding out the pressure of the liquid inside the pipe. Okay. This one is, I just showed you for understanding it more clearly. The diagram is a bit more clear. Okay. Now we can say the last class, and I told you that there was some mistake in the diagram last class. So this one is clear, I think. See, the bottom level of separation is taken as datum. That is the liquid in the pipe comes down, and where it meets the mercury or heavier liquid or manometer liquid, that line is taken as xx, that is the datum line. In the last class, some problems in the images, some mistake was there. That time I pointed out. So you have to correct it. Okay. Now we'll move on to find the equation for negative pressure or vacuum pressure. Well, we discussed the equation or derivation to find the equation for calculating the pressure for gauge pressure. This one is vacuum pressure or negative pressure. Okay. Negative pressure in the pipe. What is negative pressure? Negative pressure means pressure below atmospheric pressure. The negative pressure in the pipe sucks the liquid in the left limb, which in turn pulls up the heavy liquid in the left limb. You can see the figure here. The heavy liquid in the right limb correspondingly goes down. You can see the pressure inside the pipe is lesser. That means lower pressure, that will sucks the manometric liquid into it. Okay. So the atmospheric pressure is more. So naturally the manometric liquid will rise up in the left limb. We can see the difference from the first image and the second one. First one was for finding out the gauge pressure. This one is for finding out the negative pressure or vacuum pressure. Here the level of mercury is lower in the right limb than in the left limb. So the line of separation between manometric liquid and atmospheric air is taken as a datum, that is xx, and you can see the height of liquid in the pipe, height of liquid from the pipe, that is in the left limb, the manometer is taken as h1, and the height of manometric liquid from the datum up to the level of separation between liquid in the pipe and the manometer is taken as h2. So h1 and h2 you have to clear it out. See the diagram clearly. H1 is the height of liquid column of the lighter liquid that is in the pipe is taken as H1, and the height of manometer liquid in the left limb is taken as S2. Okay, now we will check the equation. Pressure in the left limb above xx is equal to pressure in the right limb above xx, that is P plus rho 1 GH1 is equal to rho 2 GH2 is equal to minus rho 2 GH2. Why it is minus? Because it is below the atmospheric pressure. So they have given it together. So P plus rho 1 GH1 is equal to minus rho 2 GH2. When it comes to the left side, it will be P plus rho 1 GH1 plus rho 2 GH2. I said P plus rho 1 GH1 is equal to minus rho 2 GH2. Why this minus rho 2? Because you can see that it is below the atmospheric pressure. It is the right limb level is lower than the left limb. That is why it is taken as negative. And now you can see that P is equal to minus rho 2 GH2 plus rho 1 GH1, or minus inside the bracket you can give it as rho 1 GH1 plus rho 2 GH2. Why the minus and minus sign is indicates that pressure in the pipe is below the atmospheric pressure, or it is vacuum pressure. Okay.